Well, in recent videos that Linda and I have done, I have included one section on load testing a battery using a Sun VAT-40 VAT volt amp test. And although the test is valid, a few things happened. First of all, the CarbonPile started to smoke and Linda turned off the recording session thinking we were about to have a fire, so it didn't capture everything I wanted, but that's okay. I should have warned her that could happen. And just because it was pulling so many amps across the CarbonPile, it got hot, normal. The other thing that I thought of is that it's very hard for anyone to find a VAT-40 in good working condition since the thing's over 40, 45 years old. Ours works great. They're very durable equipment, but very hard to find unless you know where to look. So I looked around and I found a few different battery load testers. This one I got because it has 6, 12, and 24 volt capability, and I can load test up to 1,000 amperes, which is a lot more than I'll probably need unless I work on a truck. This I got from an Amazon reseller. The brand name is Solar, but I've seen other brand names with very similar equipment. I've seen equipment like this that is rated at 500 amps for 12 volts only. If you want to plan to do automobiles, that is a perfectly good piece of equipment. Currently, about 5 months into the year 2022, they run just a little over $100, maybe a little under with shipping. Very reasonable price. So what I'm going to do is I'm going to, using a different car, show how to use this to load test a battery on our 73 Mach1, which right now has no starting or running issues. But you'll notice the battery shows it's a little on the low side for testing. And that's okay. We're showing right now is putting out about 12 volts. It happened at 12.2. And that will be adequate for what I'm going to do. Now, the other thing is load testing. Typically, a person looks at the battery. Under somewhere is usually a label that sometimes comes off later with the cold, cranky amperage rating of the battery. To load test it, you take that cold crank amp, which is acronym CCA, divide it by 2. For a car this size, with what looks to be a 24F battery, the cold crank amps ought to be about 400 amps, might be higher. But if I take 400 divided by 2, we get 200. So I'm going to load this down with this CarbonPile dial until this top black marker comes up to 200. When I do that, I count about 15 seconds. And the idea is for this voltmeter to not drop below 9.6 volts in that 15 seconds or so. If it does, we have a weak battery, has to be charged up, which is possible because we haven't put a charger on this or run it for a little while. And the other thing is, if it's a fully charged battery and it drops about 9.6 volts, it's an indication that there's a problem with the battery itself physically, where perhaps sulfation of the lead plates got broken off during excessively high rates of charge, or that the plates are sulfated so badly that the sulfate compound isn't dissolving into the electrolyte, which is sulfuric acid, during a recharging session. In either case, the simple process is replace battery. If you don't want to do that, you can try doing a very slow regeneration of the battery with a modern battery charger. Often, sulfated batteries can be brought back like that. Now, the other thing I'm going to do after I load test this is I'm going to do a cranking ampere testing. I'm going to use a handheld ammeter, and I'm going to use a remote starting button connected to the starter relay that cranks the engine to show how many amps the starter motor is pulling during cranking. While I'm doing that, I'm going to do some changes to the electrical system of the starter relay. Starter relay has 4 terminals. A big positive terminal goes straight to the positive cable of the battery. You can't see it from that perspective, but right across there is another large cable. It goes down to the starter motor. Here we have what's called the I, or ignition terminal. I'm disconnecting it. What the I terminal does is when the engine's cranking over, it sends full battery voltage to the ignition coil. I don't want the car to start, so I'm unplugging that. I don't want to start while I'm testing. The other wire is what's called the S, or start terminal. And this is the one that is fed by the current that goes to the ignition switch when we're in crank or start mode. It then flows through a neutral safety switch on the transmission, and then up here, that's what causes the starter relay to engage. Anyway, we'll test with the battery first. Now, when I put the ampere load on this, just to remind Linda, and for anyone watching this, if any smoke starts coming out of here, to some nominal degree, it's okay. This is brand new, I've never used this before. So I'll put this up to 200 amps. I'll start counting 15 seconds. Allegedly, this has a timer that will sound an alarm when I hit 15 seconds. I don't know if it works or not, or if it came with this particular model. Okay. Two, 3, 4, 5, 6, 7, 8, 9. Okay, take a look, and you can see we fell below 9.6 volts. The other thing I found is trying to turn this knob off did not let the carbon block stop working. I had to take the cable off.
And it's not smoking, but I smell smoke. So that's normal, I guess.
It's not abnormal.
I smell burning.
Yeah, that's the CarbonPile burning off residue in the wiring. That I had to take off this clamp to stop the amperage flow concerns me. I couldn't turn it off down here like I should be able to, even though I went all the way to the left on the knob. But nonetheless, oh, and the other thing, if you're watching the amperage needle, I was pulling closer to 250 amps because the knob doesn't have the fine control to it like I'm used to in the VAT-40. That's forgivable. So even though the battery shows a drop of 9.6 volts, I was loading it unusually heavy, probably unfairly heavy during the test. It has been enough to spin the engine over, fire it up and go. The battery is an older one, about 2 years old. I usually find batteries have to be replaced every 2 to 4 years. I don't think I have to replace this yet, but after testing it, maybe I will. We'll see. Anyway, all this to one side. That is the load test on a battery. Now, we'll do the amperage test during cranking.
Should I be over there and
I'm going to point it right to you.
okay, I'm gonna
So you'll be able to see it if you come right here.
get right here and
Okay.
get closer.
When I first start to crank this, the ammeter is going to jump up and then it's going to settle down. I'm not worried about the spike in amperage. I'm more concerned about the continual amperage draw while it's cranking over. Okay, so I've connected to the S start terminal, the positive side of the battery. For the ammeter, I go from an off position to 600 volts amp, and you see it shows negative 10,000. That's about less than 1 amp being drawn. Well, I need to zero this out. So it's ZF, zero function. It's showing DC current, not AC. We want DC, direct current. I hold this down for a moment and it goes to 0, or close to 0, but 0 is at 0. So now what I'll do is I'll put this clamp around the battery cable. Now, unfortunately, it's reading upside down, but we'll have it on video. And you'll be able to see how many amps are going through here. Okay, almost 200 after it spiked. And it only spiked for a moment. 200 amps is pretty good. If we got very, very low amperage and a slow crank, that's indicating we have resistance between the battery post, positive, negative, and the starter motor. It could be that the post and the terminal lugs have to be taken apart and cleaned. It could be that the starter brushes are worn and not transferring current to the armature with the brushes. It could be all kinds of stuff like that, indicating it's not getting enough power to turn. If it was a very high reading, say 400, 450 amps, more than 300 typically, that would indicate that the engine has a lot of resistance requiring more amperage going to the starter to turn it over. Or you could have a short in the windings in the armature of the starter motor that's pulling more current but not generating the electromagnetic field in these two to crank over. Either way, typically that's a starter issue. 200 amps or just under it is about what I expect for a V8 engine from back in this era, so I'm happy with that. Now, this little volt ammeter does additional stuff. I'm going to start the engine in a few moments and then show how to go through a series of tests. Some of the tests that you have available to you to check the charging system of these first generation alternators from back in the 60s and 70s. I'm not going to show every possible test because there's so many of them, but I'll show the general ones and one that I find very useful. So we'll be back in a few minutes. The engine started very nicely. It's a little loud, so I'm going to put it here. With this empty pressure, I go to the 60 amp scale, 60. The zeroing. We're going to check that the amps are being sent back to the battery. Check the voltage. I'll put my electrodes on here. Go to the voltage scale. I zero it. All I'm going to do is check battery voltage with the alternator working. 14 first thing I'm going to do is zeroing the amperes again. Is I'm going to there. I'm going to make sure there's amperage flowing through the field circuit. And I have 4.8 amps going through it. Now I'm going to see how many amps are coming more from the alternator idling. Right now we're getting 4.3 amps into the battery from the alternator. There I'm getting between 25 and 36 amps. So basically, what I did is I told the alternator when I gave it all the juice, give me the most you can, and at idle speed, it maxed at 38.6 amps, but it had about 26 amps on average. That is net amperage. Total output of the alternator minus what's being taken by the ignition system to run it. 36 amps at idle is not too bad. I've run this before at higher speed, 2000 RPM, and we're getting 75 amps out of it. It's a rebuilt alternator. Rebuilt alternator with high performance amperage output components. Okay, that concludes the quick test of the Ford alternator.